The thiol tube is a glass tube which contains heating oil. The shape of the thiol tube allows for formation of convection currents in the oil when it is heated. You will require a thermometer, a capillary tube, and a rubber band or small slice of rubber hosing to attach the capillary to the thermometer. You will also need a Bunsen burner, a striker, and of course, your sample. The first step requires you to pack a capillary with a small amount of the sample. First, gently press the open end of the capillary into the sample until the capillary contains a height of approximately 2 millimeters of the sample. There are several ways of transferring the sample down to the closed end of the capillary. One way is to gently tap the capillary on the lab bench until the sample drops down to the bottom of the capillary. Alternatively, you can use a coin with a milled edge or a small file to scratch the top of the capillary. This causes vibrations which will cause the sample to drop down to the bottom of the capillary. Another way of transferring the sample would be to drop the capillary down a piece of glass tubing on the lab bench. This forces the sample down to the bottom of the capillary tube. A column of about 2 millimeters high in the tube is all that is required. Carefully place a rubber thermometer adapter on the thermometer. This allows secure positioning of the thermometer in the thiol tube. Then use a rubber band or small slice of rubber hosing to attach the packed capillary to the bottom of the thermometer. Make sure the bottom of the capillary is aligned with the bottom of the thermometer. It is important to position the thermometer with the rubber well above the level of the oil. This is because the oil expands upon heating, and if the rubber becomes immersed in oil, it may soften and break, allowing the capillary tubing to fall into the oil. Gently heat the oil by moving a small flame back and forth along the sidearm. You will probably see the convection currents and circulation of oil through the thiol tube. In order to obtain an accurate melting point, the rate of heating near the melting point should only be 1 degree per minute. Therefore, to avoid the experiment taking a long time, it is a good idea to do approximate determination with rapid heating first, and then do a more accurate determination with a new sample and slower heating near the melting point. Similar to the Fisher-Johns melting point determination, you should be looking for the point when the crystals start to melt. Record this temperature. Once all the crystals have melted, record that temperature as well. This will give you a temperature range. Repeat this melting point determination with a new sample until you obtain consistent measurements. It will take a while for the oil to cool, but you can start again once the temperature has dropped to at least 20 degrees below the approximate melting point. When you are repeating this procedure, remember that you cannot reuse samples. You must use a fresh sample each time because some compounds decompose upon melting.